Hi, welcome to a lecture video for IDEA 9103 Design Programming. This video is going to be on pseudocode, which is a good way to help you plan your algorithms. So first of all, what is pseudocode? Pseudocode is a plain text, usually written as code comments, within the same place that you're going to write your code. So what you do is write down in very plain language what you want your code to actually achieve. And there are many benefits of this, which I will go over. Why is it helpful? It allows you to understand the whole program, because you can see it from the bigger picture before you begin to code. And this can be very useful because it helps you detect issues with the structure of your code before you spend too much time on the little bits. And this allows you to take on those small segments one by one and sort of remember. It's like a little bit like a to-do list. It also gives you an understanding of how each part is related to another, which can give you much more insight of how to make variables, or what variables will be needed, and also what sort of functions and things would be needed. So, refresher on an algorithm. An algorithm is a set of rules or instructions that are followed to achieve some result. So, I've given the simple analogy of a recipe for a cheese sandwich. It's very basic. It's a cheese between two slices of bread with maybe some butter. So looking at these steps for this recipe, we've got place 2 slices of bread on a plate, spread butter on both pieces of bread, place a slice of cheese on the bread, and then place the other piece of bread on top. Now, a robot might interpret those instructions a little bit differently. When we look at a recipe for a cheese sandwich as humans, there's an assumption there that we know enough about sandwiches or preparation of food to be able to take these instructions and interpret them into what makes sense. With a computer, there isn't that interpretation. A computer will do the things exactly the way they are described. So let's look at some of the issues that a computer would have with those instructions. First of all, we said place 2 slices of bread on the plate. Would a robot know how to open a bread bag? Would it know how to put the pieces of bread down? Would they be side by side or on top of each other, or would it scrunch them into a ball that would be unusable? Spread butter on both pieces of bread. We didn't tell it where on the bread to spread the butter. We didn't tell it to use a butter knife. If we were breaking down these exercises, these instructions for a robot, we would tell it to first go get the butter knife, take it out of the drawer, hold it in the hand, open the butter lid, use the knife to pick up some butter, and then smoothly put it over the large flat surface of the bread. We would have to be very specific. Now, what about the cheese? The cheese could be in the fridge. We haven't specified where or how to get that. If it's in some sort of package, or if it's in a block that needs to be sliced and some preparation that needs to be done to the cheese. So obviously there's issues there. Also, with placing the last piece of bread on top, even if it's completely got all of the steps previously right, it might end up putting the butter on the outside, which would make for a very interesting sandwich. So, breaking down the steps for a robot or a computer would be a long list, but very specific. So we'd say open the cupboard, pick up the plate, place the plate on the counter, and so on. And these would be very explicit instructions that a computer would have to follow. So when you're thinking about coding, start to think, how would a machine interpret these instructions? Now, how do we write pseudocode? I have mentioned before that we've write it as comments within our code, and then what we do is we fill it out with code once it's all written. But first, our first step is to identify the goal. I'm going to be using the example from week 2. You might be familiar with this. And we're going to be walking through how to write an algorithm for this, just for the purpose of explaining pseudocode. So our goal is to recreate this image that you see on screen. So after we've got our goal, we need to break it up into basic instructions. So I've put a list here, drawing the background, drawing this long black line that you see, drawing the short white line that covers the big black circle, drawing the small black circle that you see, drawing the large black circle, and also drawing the white circle with the black outline. It is not quite white, but same color as the background, but for this example we'll just pretend it's all white. So now our next step is to consider the order of instructions, because within code the order of execution is important, and we know that within P5 the layering of shapes is important, so that the order that those instructions are given to the machine are the order that they will appear on the page. So first of all, drawing the background is in the right place. We probably want to do that first because everything else is on top of it. The black line appears on top of the white circle, so it must be drawn after the white circle, so we're going to have to move it to the end. What else is wrong? Well, the large black circle appears on top of the white circle, so it must be drawn after the white circle, so we're going to have to swap these two. Alright, that's done. The white line appears on top of the black circle, so it must be drawn after the black circle, and almost after everything else, so let's just move it to the end. Alright, now sometimes it doesn't really matter what order things come in. We moved the white line to the end, but really it wouldn't matter if it covered the black line or the black circle, as long as it's drawn after both. It shouldn't matter. And similarly, the long black line drawn after the black circle doesn't really matter because they're the same color. But it's a good idea to check the order of execution where it matters. As you become quicker, you can quite often do these first few steps in one go. You can identify the goal, break it up into instructions, and determine the order all at the same time. So adding detail to each instruction is where we get to the more specifics. We expand these instructions into something that we can turn into code a little bit easier. So if we start to look at these instructions that we've written, and we think about what kind of parameters and conditions they require. So for example, the background, we know that that takes a parameter of color, so we have to ask ourselves, what color is the background? Similarly with circles, what are their positions and radiuses? With lines, what is their start and end point? And also, because these are shape drawing functions, we also have to consider what styling functions need to be applied before we draw. So, breaking up this particular line, draw the small black circle, let's think about what kind of things we need. So first of all, we need to set the fill to black, and this sets the color. That has to be done. We also need to either set the stroke to black or turn the stroke off. It sort of depends on how we want to write things, but it is worth putting into code that something needs to be done here. We also need to specify the position. So I've chosen to specify this relative to the large black circle. So I've said positioned left of the large black circle, x plus large black circle radius, which would put it about there, and slightly above the black line y, with a diameter of around 10% of the large black circle. These values might not necessarily be right, but it's important to just kind of ballpark them and figure out what they're relative to. So in this case, they're relative to the large black circle. Now we turn the pseudocode into code. So I've gone through and changed all those instructions to their longer form, given their requirements and things, and we'll have a look at that. So we should be able to see what variables are needed, where they're frequently used, when they're first used, when they're last used, and sort of that gives us an idea of the scope that they're needed in. We'll also know which functions we need to call and the order that they should be called in. So we have our code. This is what it should look like. I'm just going to switch over to my editor and start filling this out. Alright, so draw the background white. It's quite an easy one. Background, and white is 255. Set fill to black, set stroke to black, quite easy that. 0 and 0. Oops. There we go. Now draw a small black circle positioned left of large black circle and large black radius and slightly above black line Y with a diameter of around 10% of large black circle diameter. Now see, this is interesting because we've identified what we're relative to, and so this is a very good place. I've identified that this is a very good place to start using variables. So if I now specify below this line that I want the large black circle's X to be in the middle of the canvas, so I'm going to go let a big black circle X equal width onto. I know that I'm going to be reusing that, so I will be able to reference it. I also need the radius. And we'll go with 100. The black line Y, which is sort of the middle line of the whole drawing, so I'm just going to call that the midline. I'll keep it specific. Black line Y. And that's at height on 2. Alright, now I have those available to me. I can actually go through and draw this circle. I'm just going to move this line down, holding Control Shift to shift the whole line. And I will draw this circle using the ellipse function. So, left of large black circle X, I will say, I'll copy this down here, plus black circle radius. Maybe that radius is a bit too big, but we'll be able to change it later by changing it up here. Although, I've made a mistake. I've just identified that that's to the right, because going to the left of something you actually have to subtract. Okay, now for the Y. It is at this space, but slightly above it, which we also have to subtract, so I'll subtract, let's say 10. Oh, I also forgotten that this circle needs to be a little bit more away from that, so I'll subtract 10 there as well. And the size, we said about 10% of the big black circle radius, so I'll divide that by 10. Wait, does that make sense? 10%, yes, divided by 10. Alright, set fill to white, set stroke to black. I've already got this one, I'm going to copy this one. Actually, I might just copy all of this and replace it. To make things a bit quicker, except that one's to black and that one's to not. Okay, I'll do this instead. So just pasting that in, and this needs to be changed to white. Go. Again, I'll fill in an ellipse function. Position right of large black circle X. So we've already got large black circle X. And again, this is a variable that we're reusing. So the pseudocode helped me identify that I would be using that a lot, and it's really helpful because then I have a variable that's being used in a lot of places. To the right would be to add. So let's add, this one's a bit bigger, so let's add around 50. But it's also slightly behind it, so I think that 50 should work. In line with black line Y, so that without any modification should do, and diameter around 70%. 70% of this radius, which would be just times 7 on 10 will do. Alright, set fill to black and set stroke to black. That's the same as up here, so I'm just going to quickly copy paste this. This is a fairly simple exercise that you should have already done before, so I couldn't imagine that you'd be getting too much out of me filling this in slowly, so I'm going to do it fairly quickly. Alright, next ellipse. The large black circle in the center of the canvas with a diameter around 100. We've already got our X that we've been using. It happens to be using the same line, black line Y, because I've decided to keep it dead center. And we've already got the radius. Keep in mind the default mode for ellipse is to do diameters, so this is going to have to be multiplied by 2. Diameter and radius. The line X is starting at, well, I've actually specified this in code, so I can just copy that over. And it's fine to write in code if you already know what the code's going to be without thinking too much. Just write it in code into the comments, and that's fine. Constant y of height on 2. Oh, yes, so those were the two x values, so I've made a mistake. I'm just going to have to add the y's there, and constant y of height on 2. Yep, there and there. And that's just because I'm familiar with the parameters. I know that it goes xy, xy. Obviously, if you're turning your pseudocode into code and you're not familiar with that, you can just simply look it up. Alright, last line. Now this one is just covering the black circle, so I've been quite specific with where it starts. Starts at large black circle X minus the radius. Should get us exactly on the edge. Oh, whoops, that's not in code. Copy. And paste. And ending at sort of the same thing but plus the radius. So I'm just going to copy that from there and change that to a plus. That's where it starts and ends in the X. I've done the strange thing again where I go XX first. I need to go XY, XY. So there's our, whoops, not there, there. There's our Y value, and there's our Y value, constant value of height on 2. See what we get. That radius is a bit too big, so I guess maybe it is in radius mode. Oops, error. It's alright. There we go. And so, without, oh no, that white line is a bit too big. Let's divide that by 2. Small errors, that's fine. Cool. That's correct, and that's pretty close to the image. So, as you learn more concepts, coding concepts, and your skills develop, you'll be able to identify places that you can implement if statements, for loops, custom functions, arrays, objects, and classes. And it'll be sort of up to you how you want to write pseudocode for those. There's no real specific way to write pseudocode. So pseudocode is your documentation. You should write it the way that it makes sense to you, because you're the one who's going to have to read it and interpret it to turn it into instructions. You always want to consider the order of execution requirements if you are using these advanced concepts or things like that. And you can use indentation and special characters or whatever demarcation you're choosing to indicate repeated code and nested code. So I'm just going to show you some examples of one way to do if and for loops, and I'm going to be looking at another example, but keep in mind that it's just one way to write it, and there's much simpler ways to do it if that's what you want. So I'm going to be looking at this one from week 2, which has nested for loops and a nested if statement. So breaking up our first identifying our goal is to draw a grid of shapes. But we can break this down into individual instructions. Obviously, with a for loop, you'd end up with a really long list of the same instruction over and over again, or sort of alternating instructions in this case. And this would be a bit long to write. So let's think of a way that we can turn this long list of instructions into a single instruction. So first off, we break down how we want to break down our goal into our individual instructions. And do we want to go with rows or columns first? I've chosen to go with rows. Now, replacing this long list of instructions, I can just change that to one instruction. Draw a row of alternating circles and squares. Now, because I'm repeating this 5 times, I could use some sort of language or predefined way for myself to remind myself that I'm looping. So I've chosen to go with multi-line comment with the heading loop and then just something specific detailing how many times I do it. So do this 5 times. Now, because this actually represents a lot of instructions, circle, square, we can sort of break this up even more as well. You could leave it at this, and if you knew how to implement this without thinking too much, by all means go ahead. But I'm just going to break this down even further. So imagining that I was replacing that draw an alternating line with circles and squares, I could just go, well, that's kind of, I could break that up into quite a few steps. It's circle, square, it's alternating, it's a pattern. I can identify that pattern and apply a loop to it. So instead I'm going to loop, draw a circle, draw a square 5 times. Obviously we can break this down even further. There's a detectable pattern here. We're drawing a circle, then a square, and so alternating here, we could simply write something like if, and use that and a multi-line comment as well to specify that we're making a decision here. So I've just chosen to use if and then specified some description, cycle through 1, 2, 1, 2, and then said what 1 and 2 are. Now keep in mind, this is just my chosen way of doing it. However you want to do it is up to you. So if you wanted to write it something like draw 5 rows, draw 10 columns, alternate based on column, draw circle or row, that would be a much simpler way to write this, and that's completely up to you. As long as you're the one that understands it, that's what's important. Alright, so in conclusion, if we're to write pseudocode, always determine the goal, break the goal into instructions, determine the requirements of each instruction, and then write your code. And the added benefit of all this is that you have well commented code. Alright, thanks for watching.